Hey guys, today we'll be solving lead code number 3633, earliest finish time. This is an easy problem on lead code and it is also the daily problem for today. Now, what have they given to us? They've given to us land, and they've given to us water. We're given an array of essentially rides that we can take and their duration, right? And the rides being the time they start. And we're given the same for water. We're given rides and we're given duration. And all we have to do is just make it the essentially we want to figure out the earliest time, in the sense that what is the most optimal way we could do one ride after the other such that the time we spent is minimal, and we classify as it being over once we have done one ride from each category, right? So that's either, so we don't have to do land and land. We can do we don't have to do land and land together. We don't have to process them together. We can do land and then we can do water and we can be done with it, right? We don't have to do land, water to land. There's no need for that. Just do one exact iteration, right? That's the whole condition. Now the thing with the examples that they've given is that they've pretty much they've done a pretty good job of explaining all the possible patterns. So I'm going to be emphasizing more on the code, I guess, coming up with the brute force solution code. So I'll just get started immediately. What we do, so there's a bunch of patterns, right, that they've given to us. And essentially all we're supposed to do is find the minimum across these patterns. So if you look at example 1, they've given plan A, plan B, plan C, plan D, right? And we see that plan A comes to be the first one because we finish a ride and then take the next one immediately, right? That's the whole basis of the question, whether we're trying to minimize for time. So we can do that with the brute force pattern. So in the sense that what we will do is we will literally calculate plan A, B, C, D and take the minimum across them. How do we calculate the plan A, B, C, D minimum? We do it both ways. So we do, if we went land to water after this, and if we went water to land, essentially immediately, what values would we get, and how, and we would just store that into our result essentially. I'll get to a bit more explanation when we write down the code. It's just a double for loop, by the way. So this is O of n squared solution, brute force. I won't be writing out the full water start time. I'll just write down water start and land start to save some time. Alright, so now let's get to finish. We'll do one, so we'll do the land way, right? Land to water. We just write that down over here. Alright, land. When do we start it? Well, we start it when we have our start and we lock into it until the duration, right? Okay, so once we're done with this, we have our time to finish land essentially. Now let's go on to the next one. So finish the both of them, right? And remember, they've given to us the earliest time. So if we finish some task at 9, right, we can still attend the 8 ride, like the one that starts at 8, because they've given us the earliest time, right? And the only difference is, well, if we do start at 9, then 9 plus the duration, not 8 plus the duration, right? So you get what I mean? We can start it, and it's just that the cost at the end will depend on the maximum value between them. And we will write down the exact thing that I just said. So whenever we finish line and the next time to start our water. Alright, now that we have that, all we have to do is just water duration, because we will be locked in for that, right? Okay, so this way we've calculated water to land, And since we've done a part of the pattern essentially, right, this would be applicable to part A, I think. Yeah, part A, because we do the first ever thing 2, right, and then we wait for that for 4, and we can come out at time 6, then we do 6 2 3, right, and we come out at 9. That's our answer in that case. So answer is just the minimum between this answer and finish both. Alright, now the next one is just the opposite of this, by the way. Now, so it's just water and water to land. So we're calculating the reverse. So lock yourself in for that ride, and once we've done that, check the amount of time it would have taken for you to do both. Same exact thing as before, right? This is pretty much like I'm saying, brute force version. So take the water and take a land start, and lock yourself in for land duration. And again, this is another plan essentially, so take your time and store your result. And by the time we have done this entire pair finding essentially, we will return answer, because we've looked for every single possible combination and we have compared it to our answer. That's pretty much it.